Dear students, very good morning. Today we are going to see the important topics under double integration. That is, in some occasion it will not be possible to do the double integration with the actual form. So for that we have to change the order of the integration. So in that case we are going to discuss the following problem under change of order of integration. The problem here is double integral x square plus y square dy then dx. So since the limits are not shown, it is not possible to see whether it is in correct form or in wrong form. Now I am taking the limit of y as x to a and the limit of x as 0 to a. So since the limit of y is in the form of x, it is in the correct form. So we can approach the double integration after changing the order of integration. Why? Because here x is in lower limit and a constant is in upper limit. So we prefer to solve it by changing the order. That is, we have to bring this x here and bring this y after x. That is, dx should be first and dy should be next. So if I am changing dx first, I cannot simply write the limits of y to the inner integral and limits of x to the external integral. If I am writing like that, it will not be correct. See, if I write this equation as 0 to a and x to a, the given function into dx dy means it is absolutely wrong. Okay, so when changing the order of integration, the limit should not be changed simply. We have to find the region of integration first. That region of integration should be found for the given function, that is for given integral, and after that we want to change it to the order we taking in the second step. Okay, that is very important. So I am splitting the question into two halves. I am splitting this page into two halves. So what is the first differential operator we are having? The integral operator is integral over x to a dy. That is, I am considering it as y equal to x is a limit and y equal to a is another limit, and also x equal to 0 is one limit and x equal to a is another limit. So now we have to choose where this region will exist. Okay, So what is y equal to x? Y equal to x means it is 0, 0, 1, 1, 2, 2, 3, 3. Both x and y takes the equal values. Both x and y takes equal values. So it will be a straight line. Okay, it will be a straight line. Okay. So I am drawing the I am making the sketch of same diagram here also. I am making the sketch of same diagram here also. Okay. So what is the equation here? Since internal limit is y, I am writing it as y equal to x. Y equal to x. Since I am going to change it as x and y. I am writing it as x equal to y. Okay. Then the second thing, y equal to a. So if I am taking x equal to a means it will be parallel to y axis. If I am taking y equal to a means it will be parallel to, if I am taking a here, that is y equal to a means x is 0, that is 0 comma a. So it will be like this. It will be like this. See, then definitely since y equal to x is meeting the point a here, at this point y equal to x and the point of y is a, and this point will be a comma a. Okay, this point will be a comma a. So our next equation is x equal to 0. So x equal to 0 is on y axis. This is our y axis. Okay, this is our y axis. Okay, at y axis x equal to 0, x equal to 0. Okay, at y axis x equal to 0. Okay, so as you can simply put, this is y and this is x. Okay, so x equal to 0 is over, and next point is x equal to a. So at this point only x equal to a, so I am taking x equal to a. Okay, this is x equal to a. This line is y equal to a. Okay, this line is x equal to a. Okay, this line is x equal to a. This point is 0 comma a. So this point is a comma 0. This point is a comma 0. This point is a comma 0. Okay, a comma 0. Okay, now I am going to draw all the lines here also. I am going to draw all the lines here also. Okay, so where comes the difference is what we are going to discuss here. So see, this point is y equal to a. This point is a comma a. and this is a comma 0. This point is 0 comma 0 comma a 0 comma a, and here it is origin. Okay, this is x equal to a, x equal to a. So now we have to identify the region of integration. See, y equal to x is the lower limit and y equal to a is the upper limit. So y equal to x is the lower limit, means this, the region should be above this. Our region should be above this. Okay, above the lower limit. Okay, our region should be above the lower limit. Okay, then up to y equal to a, and the regions should not exceed this upper limit. Okay, our region should not exceed this upper limit. Okay, so our region of integration is existing here. Our region of integration is existing here. So for this we have to draw the internal strips. Okay, so now we are drawing the internal strips, that is x varying from, so y varying from x to a, y varying from x to a. Okay, so this is our internal strips. Okay, now we want to change the order. Y as x, that is dy as dx and dx as dy. That is, we want the given integral to be double integral x square. Okay, x square plus y square, x square plus y square into dx dy. Okay, if x is the inner integral operator, if x is the differential operator, if d is the differential operator depending on x, then our strips should be horizontal. If y is the integral operator, then our strips should be vertical. Okay, so now our strips should be horizontal, that is parallel to x axis. Okay, so we have to change this, vertical strips into horizontal strips. Okay, into horizontal strips. Okay, this is our horizontal strip. So now identify what is the inner integral operator dx, and its limits are, here see, here x equal to 0, and it is varying up to the line x equal to y. So here x equal to 0 to y, and for y, and to find y we have to identify region where it exists. So the region is existing from, see, the region is existing from here. This is the lower limit, as we have seen already. This is the lower limit, okay, and this is the upper limit of y. This is the upper limit of y, and we know that our region of existence is given by this, okay. This is the region of integration and the strips is between, okay. So what is this point? This point is 0, 0. This point is 0, 0. Zero, 0 means the value of y, the limit of y is varying from 0 to 1. See, sorry, 0 to a, 0 to a, okay. So zero to a. It is 0 to a. Now you can easily identify the difference. Now you can easily identify the difference that, see, the figure is transformed. The figure is transformed. Also you can see the given integral equation is also changed. The given double integral equation is also now changed, okay. See, this is our double integral equation. Integral 0 to a is same 0 to a, but integral x to a is changed as integral 0 to y. X to y is changed as integral, x to y is changed as integral 0 to y. So if it is not possible to go for this integration, we can change the order of integration, we can evaluate. That is the main concept, okay. So since here the lower limit is x, and I think it will be weird to choose the lower integral as the variable. I am trying the way to solve by changing the order of integration, and this is the new order. See, here y is changed to x and x is changed to y. So, and for this we are going to evaluate, okay, and for this we are going to evaluate, okay. So after this we know how to evaluate it. So here the equation is double integral x square plus y square plus y square of dx and dy. So here it is 0 to y, here it is 0 to a, okay. Now the external limit will be 0 to a. Okay, the inner limit is x square dx will become x cube by 3 plus xy square, x y square, x y square, and for this we have to substitute the limits. So for what? For the variable x we have to substitute the limits. So we will have integral y cube divided by 3 plus y cube and dy, okay, and dy, it is 0 to a, it is 0 to a, that is equal to we can easily take we can take LCM also. So I am taking LCM, that is I will get 4 by 3, yes, constant, 4 by 3 integral 0 to a y cube, okay, y cube dy. So and for this we will get y power 4 by 4, so 4 by 3 of y power 4 divided by 4, y power 4 divided by 4 of 0 to a, 0 to a, that is equal to 4 divided by 3 of a power 4 divided by 4, a power 4 divided by 4. So this 4 1 4 will get cancelled, so finally we will get a power 4 divided by 3. This is the final output, this is the final result. So we have evaluated by changing the order of integration, okay. See, for this figure, okay, for this figure we have considered the order of integration as dx and dy and considered the corresponding limits, and we have evaluated it and found the result as a power 4 by 3. I hope you all enjoyed this video, and if you have enjoyed this video, kindly study the problem and prepare for your exams very well. We shall see on some other different problems very soon. Thank you for watching this video. Thank you all once again.